Hello, welcome. It's time for Catalog and Cocktails. It's your honest, no BS, non-salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime product nerd at Data.World, joined by Juan Cicada. Hey, Juan.
Hey, Tim. I'm Juan Cicada, principal scientist and the head of the AI lab here at Data.World. And as always, it's a pleasure to take that break and have a conversation about data, about AI, a lot of AI stuff. And today, super excited because we're going to have somebody who I've realized that I've kind of been wanting to connect with him, and over so many years, it just hasn't happened until finally right now. And that is Bob van Luijt, who's the co-founder of Weaviate. Bob, how are you doing?
I'm doing well. Thanks for having me. This is great. A little bit early for me to have a cocktail though, but for the rest, I'm doing great.
We always say, right? It's not only 5 p.m. somewhere, but it's sunset somewhere, right? I think that was somebody's name in the podcast. So, all right, Bob. Well, we're going to be diving into what Weaviate and vector database and all the AI stuff. But before that, quick, what are we drinking and what are we toasted for today? I think we're all on coffee right now, but any special coffee or whatever?
I just a regular cup of coffee. I'm staying in a beautiful. I'm currently in a houseboat in Marin, so just north of the bay. So that's absolutely beautiful here. So what we're toasting for? So it's a. I was reading something this weekend about game theory, because that I like that stuff. I'm interested in that kind of stuff. And I was reading about like games that were played to solve the prisoner's dilemma. And one thing that made me very happy, and that's something I would like to toast to, is that if you can have different strategies, right? So you can have a nice or forgiving strategy, or you can have an aggressive strategy. And turns out that over time, by all the research that is done, is actually being nice. The nice strategy seems to always win over time, and I think that's nice because in Weaviate we have like a value. Our first value is like kindness. And I was reading this about game theory. And I was like, hey, isn't that a beautiful thing? So actually, in nature, there's like proof that doing the right thing works over the long term. So that's what I would like to toast to.
I love that. That's fascinating.
Can't top that. To be kind, to be nice.
Yeah.
Cheers to that.
Cheers.
That.
Be kind.
Yes.
All right, we got so much to touch and talk about. Let's dive in. Bob, honest, no BS. What is a vector database?
So a vector database is a database where and this mostly has to do with the search index. The vector embeddings are the first class citizen, right? So we're in a time series database, everything is around time, right? In a graph database, everything is about nodes and edges. So in the vector database, the first class citizen are these vector embeddings, and the vector embedding itself is as old as math. I mean, exaggerating a little bit, but they of course started to play a prominent role in when machine learning came in the last wave of machine learning, if you will. And that's what a vector database does. There's way more to it, because it's also, but we probably dive into that as well. But it also has to do with how developers interact with the database. But at its core, at its heart, if you, as I always like to say, peel off the onion, at the heart, it's about the vector index that sits in the database.
Yeah, that makes sense. And I know that vector databases aren't super recent. I mean, they're maybe a little bit more recent, but they're not super recent, only to sort of this recent AI craze. But I know that because of Gen AI really taking the forefront, I think, in the technology mindset in the market, right? There's become renewed interest and focus on vector databases. Can you talk a little bit about that? Like what is this renewed focus, and why is vector databases such a hot thing right now?
Yeah, so the everybody who's ever worked with machine learning models, can be open source. If you can find Hugging Face, or you go to one of the proprietary models, doesn't matter. You often see three types of models, right? I mean, there are more, but generally speaking, right? You see generative models, and that's the whole what's happening now, where the whole started by it already existed, but really the world saw it through ChatGPT, right?
Mm-hmm.
Then then sometimes we see re-ranker models, and we'll talk about what they do in a bit. And you see these embedding models. And for a lot of people, these embeddings models are a little bit weird because you throw a text at it, or nowadays it's multimodals or an image or audio, you throw it at it. And what you get back is an array of floating points. That looks a little bit awkward. I remember that I saw that for the first time very well. That was 2015. And I was like, huh? What's this? And but what it turns out, what we can do with that is that we can search with it, because it's a spatial representation of whatever data we have vectorized, right? And so what we solve with that is like search and recommendation solutions. Now, where it becomes interesting is that just comparing vector embeddings with each other and doing distance calculations, that's not that hard, right? That is just, so you take one vector embedding, you compare it to another one, and you say, okay, what's the distance? And then you compare it to another one, and you say, what's the distance? And so on and so forth. So if you have like 1,000 embeddings, that's a couple of lines of Python, right? And you're good to go. Where it becomes, the problem with that is that it's brute force. So, it gets slower and slower and slower over time, the more embeddings that you add in a linear fashion, right? So now these algorithms started to emerge, often known as approximate nearest neighbor algorithms, where you basically say, well, it's a space, right? So we have nearest neighbors in that space. How can we in a more optimal fashion find what these nearest neighbors is, rather than doing that very simply by brute force comparing them to each other? And the A is interesting in this abbreviation because the A stands for approximation. So the cost, the thing that we have to quote unquote pay, is accuracy. Now, bear in mind, these accuracies are often in the 99th percentile, right? But still, it's often not 100%. And you can actually tweak them, right? So you can say, like, I'm accepting, to accept a lower accuracy for a significant speed bump, right? And here it becomes interesting, because now the way that those kind of indices are built, the way that those kind of indices sit in the database, the way that you scale and shard a database and manage the database and so on and so forth, turned out to be a unique problem. So therefore, we started to see these new flavor of databases where people said, like, hey, wait a second, this is not just this is actually a significant technological challenge.
So this has been the evolution of what you're describing from a technical perspective, understanding how to go manage, if you're treating this vectors right now as a first class citizen and you're doing some type of querying, in this case, right, you want to do nearest neighbor, you have to have these first class types of query approaches. And you realize if you're treating it as a first class, you're going to have to go deal with problems that treat them also as first class, right? Because I think what we're seeing right now in the market is people saying, oh, that's just a feature. And like, oh, all these other databases can add that too. But then is the argument then they're not treating those as first class. Therefore, they're going to be maybe good enough for some use cases, but then suboptimal for other ones. Or so what I want to get towards is I'm out there on the street hearing vector databases and other things. People like, that's just a feature.
Yeah. So and the answer is that's true, right? So and let me say that is true for any other database that exists. I can store a JSON object in Postgres. Why would I use MongoDB? Well, I can tell you why you might want to use that, right? I can make a graph relation in Postgres. I can make an argument why you want to use a dedicated graph database, and so on and so forth. But by the way, this is, if you look at history, anytime a database for a new data type emerged, but we can do this in X being general purpose database is as old as databases are, so that's fine. Actually, I would even go like a step further. I think that's a beautiful thing, because I think, like, as I always tell our team, it's our champagne problem, right? Because if somebody said, like, vector embeddings, really, we're not going to spend the time of integrating that. That means then, okay, great. Now you have like a category in a niche with a very unique index that nobody wants. So the fact that everybody's integrating is a great thing. But I always say, building a database is a bit like an avocado. So everything that we've been talking about now is the pit of the avocado, right? It's a hardcore tech thing, right? And we can talk for hours about that, right? So we can keep drilling into that. But building a database company, there's also the developer experience around how you're interacting with that database, right? And it's all that combined is what makes the vector database unique.
That's a great t-shirt quote right there. We have build a database like an avocado. Then you have it's like the pit. That's brilliant, and that's totally. I mean, I've lived this, right? My background is all the RDF, semantic web, graph stuff, and it's just very early on. People was like, "Well, I can do this in databases," and like 10 plus years ago, that's why I always had problems publishing in the database community because I'm like, "Well, no, we can already do this. We don't need that other stuff." Like here it is, right? I do this all the time, right? Totally get the history. I've lived that part from the databases. So, but okay, so. Let's start unpacking this, right? Let's do the avocado, right? Okay, that's the pit, and yeah, we can dive into the pit, and I'd love to do that, but let's extend it. So what? Where does vector databases here fit in the broader picture of AI? And as you can imagine, let's dive into this whole RAG architectures and basically these AI native applications that we want to talk about.
Yeah. So I mean, the database is like any other database, a piece of the core infrastructure. So what you often see with these new paradigms is that a stack starts to emerge, right? So, people listening might be familiar with things like the LAMP stack, right? Back in the days, that's how I started my career.
Linux, MySQL, PHP.
Exactly. Yes.
The first company I did in 2004 or 5. That was all on a LAMP stack.
And then you got the mean stack, right, with Mongo.
Exactly. But now, if you add, what does the A in the mean stack stand for?
Angular, right?
Angular, yes. And what's very interesting about that is that it's very JavaScript heavy for a good reason, because the developers using that kind of infrastructure, and I'll get to your answer with a little detour, but the JavaScript element there is extremely important when you're building web apps or normal apps, right? Because it's all JSON going back and forth and God knows what. So that's a very logical thing. Turns out that the lingua franca in AI is not JavaScript. It's Python. So that means that the way that the majority of people interact with the database is Python-esque, right? So in our case, the database itself is built in Go, and there's C optimizations in there. There's even assembly optimizations in there, because you're a database, that's what you do. But the way that the developer interacts with it is Python-esque, right? The majority of developers, not 100%, but the majority of developers use Python. So what starts to happen is that the way that you interact with the database, the way that you bring the models into the mix. So again, it's no BS, so I will definitely not do that, but I have to explain this for the listeners to know what I'm talking about. So with Weaviate, you can also directly integrate the model. So you just throw data at it, and it takes care of vectorization for you if you want to. You don't have to, but if you want to. The way that developers do that, the stack that he starts to emerge on that, so that includes the language, that includes the core infrastructure, and in the case of AI, the machine learning models, is completely different to what we've seen before. And that's the flesh of the avocado, if you will, all right? So that is the how we help people to build these applications and bring them to production. And the role that the database plays in that is that it's core infrastructure. And these new use cases started to emerge. You touched upon RAG, but RAG is that's step one. There's so much more happening there. It's all still quite primitive. Mm-hmm. And there's so much happening, and we can double click on all of these things to optimize it, make that better for the users. So it's a completely new stack that's emerging.
Okay, so let's dive into that. So what is the stack as of today, right? We're in April 2024, right? What does the stack look like today? And what is the approach to using that? Like, what are the applications what is the architecture looking like with that stack? And then where do you think this should be going towards?
Yeah, so we have the models, of course, because it starts from the perspective of the models, right? So And the models are super interesting in itself in the stack because the models they have, the majority of models now currently are consumed through APIs. That is for production cases sometimes suboptimal, right? So what's now happening with the open source models is also super interesting. But that's part one of the stack, the models. We can double click on why that's different in a bit, but that's okay, the models. Then we have the infrastructure. So that is a combination of model serving and the vector database. So for example, tools like Olama and that kind of stuff, they help serve. Then we have the so we have the models, we have the database, and then sometimes we have like stuff related to the to ETL, I guess, if you will, if I'm or the glue, to glue stuff together. So more ETL like is something like unstructured. Of course, we have a length chain, llama index, those kind of things. So that's more how people glue things together. So that's how that stack is emerging right now. So the models,
So
database, yeah.
Okay,
yeah.
so the models, right? Like all the existing models you have in there, the infrastructure. So you're serving these models. I like you do that. So that's going to be like using these llama index or lang chain, all that stuff. You have your vector databases. So that those two will fall in infrastructure. And then we talk about the glue, the ETL, the orchestration. But this is one first. I think the assumption is that this is always we're talking about unstructured data. Well, that's one question. And then second is how is that glue ETL orchestration being done? Is that just Python or is that something else? Or people are starting to create tools around that?
No, so just make sure. So I would say in the glue, that's it. That's the tooling, right? So that's where a lang chain, llama index, etc. sits, right? So and what I meant more with serving is like tools like Olama and those kind of things that just focus on serving. Yeah, but you also have Ray and those kind of things, right? So models, database, vector database, model serving, tools, if you will, right? So in broad bucket. So those four things start to emerge, but it's still moving about. So because, for example, what I said about the models, that's super interesting, right? So the model serving a model is hard, and especially if it's for production use case. However, a lot of work is being done by the community to actually optimize that. And now with the leaderboards in the quality of models, starting to flatten out, we're starting now to talk about percentage points, and that will probably be less, couple decimal points in the not too distant future. Other questions that play a role, right? Price, how much does it cost? Latency, those kind of performance kind of questions. And we might look at a seismic shift there, right? That we say, okay, actually, it now becomes easy enough, to run that myself. So I'm curious to see what will happen. And business wise, selling a model is super interesting because it's stateless, right? It's like the moment the model is out in the free world, like an MP3 file, it's out there. So these companies building these models, it's very interesting to see what will happen in the near future, how they will present these models to the world.
Interesting. Yeah. No. So each of these pieces has its kind of unique dynamics, and it's different than what we've seen with some of the stacks in the past, right? It's not like, hey, replace database with something, replace the app layer with something. There's some corollaries, right? Maybe things like LangChain are a little bit more the app side of it, right? The infrastructure, you got database components like a vector database, right? But then the models are a bit of a new component, sort of almost like a back end component that's a part of all of this. Vector databases obviously plays a really key role as part of this stack. I know, how are you looking at sort of some of the use cases around the vector databases, around AI? And then also, I'm kind of curious about how are you looking at not just unstructured data, but structured data as well? Are you seeing use cases where folks are trying to use vector databases for both unstructured and structured sort of data use cases? Or do you see, knowledge graphs or graph databases, or other types of things start to work their way into the stack as well?
Yeah. Maybe it's interesting to answer this in a reverse order, right? So
Yeah, sure.
So first of all, yes, because if all these databases start to accept embeddings, then of course, we start to see use cases emerge in that domain as well. And it's just super interesting to the moment that you add an embedding to a data object, just let alone if that's like structured or unstructured, you just give yourself the different opportunity to index and to search through the data, right? So it's like it's very much like in a traditional, MySQL database, or whatever, you said like, yes, index this column. No, don't index this column, right? So what we simply can do is that these floating points this array of floating points that we store in a column or in a graph or wherever, we can say, okay, yes, index them. The use cases that we see that start to emerge out of that is the very first, very basic one. The one that was the low-hanging fruit is what we like to call better search, right? So it's like because funnily enough, if you think about it, like search plateaued in keyword search, right? And then I'm talking purely about text for a second, which is very optimized. And I mean, the tool to work with is Lucene, of course, right? So that we see that comes back everywhere if we deal with keyword-based search. That's under the hood of all these amazing tools that are built over time. Now, the question is like, if you add vector search to that, is that an add-on? Or do we actually reverse it? Is that the engine, right? And for a vector database, the latter is true. So that brings me to the use cases. So if you have use cases that are very focused on unstructured data, and then the question is like, define unstructured. That's actually not that easy. But these unstructured data sets, and then if you look like how much unstructured data do we actually have in the world, that's estimated of like, what is it, 89% or something. These numbers are huge. So the first use case is very search and recommendation focused. However, the second use case that came out of that is something that also started to emerge. That is the RAG use case, the retrieval augmented generation. But the third one is also emerging, and that's what we like to call generative feedback loops, right? That's born out of RAG. So we can double click on all of those. But now these unique use cases for the vector database start to emerge, and that's a super interesting time to it's just super interesting. It's super exciting.
Let's double click it. So I think search recommendation got it RAG. There's so much stuff about that already. This third one, this is new. Let's unpack that one. Generative feedback loop.
Yeah. So if you have a RAG pipeline, and I'm going to assume that the audience can kind of visualize what that looks like, right? So we augment something generated with something that comes from the vector database. That's a one-way street, right? So that is like, we have a query. Candidates are selected from the database. These candidates are part of the, in this case, the prompt. And then something comes out at the other. That's a one-way street. The feedback loop, as you'd already might suggest, is that you actually attach that output back with a vector embedding into the vector database. So what you now can start to do is that you basically, as I always like to say, you can give CRUD support to the model. Oh, sorry, the CRUD access to the model. So you can tell the model, hey, there's something in my database, and it might be wrong. Can you fix that for me? Right. So you give it an instruction to generate a generative feedback loop. So the example that we have on our website is with Airbnb data. Is that we're saying there's Airbnb data in this Weaviate, but some of it is missing or some of it is wrong. Fix it.
Okay.
Yeah.
Should that be fixed in the source? Because the vector database is not the source. So you're going to fix it in the vector database, but the actual source is wrong. So it's a Band-Aid.
Why can't the vector database be the source?
Okay, you're assuming it's the source, but usually it's not the source.
No, but I mean that depends, right? So sure. But the thing is, the power sits in the fact that when you store it back, that it gets an embedding, right? So you want to be able to retrieve it again to create more loops.
I get this, and it's really interesting to see. I like how you started off saying, which is true, which is that there's this one-way street, and I think that's how it's all been going on in the last here. And that's the low-hanging fruit, right? Just to go do this. But when people start using these applications, you're right, like, wait, there's I want to go back. I mean, at the end of the day, it's like these agent frameworks. I mean, go back to like you're setting up a state machine, you're doing some planning, you're figuring out all these things. It's like there's not one-way street. It's going in circles and going all over the place and feedback loops all over. So like every if you're thinking about an agent framework that you're setting up, every node, every state there is going to be talking to something. So you're hitting back that vector database for multiple things or any type of database in there. So I think that's this makes a lot of sense, and I'm glad you're bringing this here.
And this goes back to the if we go back to the avocado metaphor, this goes back to the flash part, right? So one of the things that we are currently working on is that if you store a data object in the database, right? You just let's take that in a Python-esque, a way. There's like you just have this couple of lines of Python. That's how you add a data object, or if you create a collection in the database, right? There's a couple of lines of code. So what we now start to do is that you can actually give an instruction while creating your collection. So the instruction might be something very simple. So it's like every data object should be in English. So now you start to add data as you've always done in a database. But if you store it in Korean and you retrieve it, then it might return it in English, right? So we really start to merge, or as we like to weave, that's the name, Weaviate, right? We start to weave the database and the models together. So the usage of instructions in storing data, retrieving data, those kind of things, that starts to become intertwined with each other, right? And a gen feedback loop is a first iteration of that.
So now you're starting to get into issues about like the semantics and the meaning. And I think one of our past histories here connect on all the knowledge graph stuff. So how do knowledge graphs fit into all of this, given your background, and how are you seeing this evolving in the future?
Yeah, so I've been I think like many people who work in the linked data space, at some point you see the light and you go like, oh, life could be so simple, right? We just define our ontologies. Then people come up with these beautiful things like schema.org and what have you. And then we're just gonna store the data based on these schemas, and then world peace, right? That's that's how we're gonna solve everything. And I was in my early 20s, I was like a big fan of that, big fan. And at some point I was because before I started Weaviate, I was working as a freelance software consultant, I guess. And I was hired by a bank, and we were talking about this because back then in banking you had something that came out that was called PSD2. That has to do with the fact, right, that the bank needs to have APIs. Long story, but that's basically what it boils down to. So I was like, this is a beautiful opportunity to just define these these ontologies, how the bank is structured, and those kind of things, beautiful JSON schemas and what have you. And then the person who hired me said, like, you can't, that's not possible. I was like, how do you wait? That's not possible. Of course that's possible. And he gave me an assignment, and he said, like, okay, I'm going to send you to 4 people, and you need to define a JSON object that represents a customer. And so I went to this first person, you spoke with this person, defined the JSON schema. I said, that's easy. So then I went to the second person, and the person said, well, I agree with this, but it's a little bit different for us. And then I went to the third person, same problem. For long story short, when I spoke with all 4 of them, I was unable to capture the definition for the bank of what a customer is in a JSON object. So what I started to learn is like, the problem is not the beauty that sits in linked data. The problem is us, humans. We do not agree on stuff. And then I was in a situation and now it's 2015, and we have a mutual friend. He was also on our Weaviate podcast, Paul Groth, right? And we spoke about this on the podcast, so I can say that here. He was the one that introduced me to embeddings. and that was back then GloV, if I remember that correctly. And with individual words and these embeddings. And the idea was born, hey, what if I take a paragraph of text that describes something, and rather as a human, I'm going to try to make that connection, this semantic relation in a linked data format. I'm going to have the model predict it, right, based on centroids of what's in the text. And my first use case actually was an IoT project for that, because I got data from different vendors, and for, I don't know, elevators, right? And then, different vendors had different definitions of their elevators. So I was like, can I connect that together based on these embeddings? Then I was in Mountain View for Google I/O, where in 2016, Sander said like on stage, hey, we're going to move from mobile first to AI first. And I was like, I know what they're doing. Of course, they do that with these embeddings. And that was kind of the history and the role. And that's how Weaviate was born. And we learned actually. So you can find stuff online of me talking about Weaviate and describing it as a knowledge graph.
Yeah, I've seen it.
And that's because that word or that terminology, vector database, wasn't used yet. And it was then with my co-founders, and I was like, hey, wait a second. The opportunity, we believe, here sits not per se in predicting these links. The opportunity sits in building a dedicated database for these vector embeddings. So that's the role that the knowledge graph played or linked data in the birth of Weaviate, if you will.
So this is really fascinating. You got into this history here, and if I unpack this, and this is my interpretation here, and I'd love to get if you agree with me or not, is at the end of the day, the knowledge graphs are done to be able to go represent our data and knowledge here in a connected way. And with vector embeddings, it's another way of managing that, where I can actually start making suggestions of what these relationships can be, right? Be able to automate a lot of that stuff that in a just without the vector databases, without the embeddings, without the nearest neighbor type of stuff, I would be doing it in a manual way or rule-based way, which wouldn't scale here. But the combination of these two is really that ideal scenario, that it's not one or the other, but it should be, we should figure out how to combine them together.
Yeah, I mean, yes, but we came a long way for that. I remember that I was at the first linked data conference where I forgot what the title of my talk was, but that must have been something like, solving unlinkable entities or something with machine learning. So it's something like that, right? Well, the audience was not impressed, right? So there was like what? With machine learning? Are you nuts? How can we then guarantee the relations? And I was like, well, you can't. But you're currently in a situation where it's binary. So the connection is there or it's not there. And with machine learning, you can predict one of the relations. So you can say, I can't be 100% certain that this relation is a thing, but better than nothing, right? And today, that's kind of common ground. Today, we're completely cool with that. But back when I started, people were not cool with that. They didn't think that was a good idea. As you guys know, the linked data community can be very, how should I say, strict.
Yeah, well, I think so. A lot of the research that we've been doing here, I think, comes more from the structured side, and I guess on some aspects you do want to. Make the suggestions and stuff, but when you're actually asking questions over your structured data, you really need the accuracy, like you really need explainability around these things. So I think that's how we're seeing where you're looking at knowledge graphs doing question answering over SQL databases, but then also you want to be able to have that feedback loop back to the user. So, you ask a question, there may be some ambiguity here. I should be able to go figure that out by looking at things in the vector database and saying, hey, do you mean this? Do you mean that? Do you mean A, B, or C? Oh, I mean this thing specifically. Okay, great. Now I know this, and then I can then then I can go down the structured kind of like accurate route using the semantics to be able to question it. So that's why I see it's both, and it's really about the use cases where accuracy are inevitable.
Yeah. May I pull my be a theoretical asshole card here? May I play that card just for 1 minute?
Please do.
Sure.
So a lot of data is textual data, right? So it's like I can make the same argument for non-textual data, but let's just also for the audience, it's easier to visualize with text. If I have a data object that contains a sentence, Juan, Tim, and Bob are recording a podcast. Right? That's the string I have. How is that unstructured? The structure in the language is very clear. So the problem with unstructured data is the longer you keep double clicking on it, if you define it and you double click on it, you're like, well, it's not that unstructured. As long as you have a coherent sentence that tells something about the data object that you're storing, it's structured. An embedding is just a different way of revealing that structure than a very plain A to B connection. It's just a little bit more elaborate, if you it's able to contain more information than a direct A to B link.
Yeah.
Right. So the argument is like what we kind of have done is that we said, like, before vector embeddings were mainstream, we had like this status quo cutoff, and everything that we could solve before that we call structured, and everything that we could not solve after that we called unstructured. Which is it's fine, but in reality, if you really double click and you look on the data you're having, it's not unstructured. So this was before I started Weaviate again in my life as a software consultant. It was like a data warehouse, and this person said there was a data warehouse with all kinds of products, and this person said, like, look, this is unstructured. So I looked at the description fields, and what this person meant was that they had factories all over the world, and the data standard that they had was everything needs to be stored in American English. But guess what? The factory in the UK wrote it in British English, and the factory in France, well, they just wrote it down in French. They were like, no, we don't do stuff in English, right? So we do it in French. So it's like, you call that column unstructured, but it's actually what it contains, the descriptions of the products. You say it's unstructured because it just doesn't adhere to your standard. But now today with vector embeddings, doesn't matter anymore, right? You can store that information in multiple languages and still retrieve it based on an English query. Or you can write it in Spanish and retrieve the data from that column with vector embeddings and models, right? So not to be too nitpicky, but if we really double click and look at what actually is unstructured data, that's actually gibberish, noise. That's unstructured data. But for the rest, there's a form of structure in there.
I think this is interesting, Bob, how you're characterizing this, because I think that by shorthand, a lot of folks look at vector databases, right? And they kind of see that a primary use case is around this sort of textual information and representing it as the embeddings, right? And tend to then characterize it as, this is unstructured information, right? And I think what I hear you saying is that that may be an oversimplification and perhaps an unfair simplification as to the role that vector databases are playing and the use cases that they're supporting, that in many ways you can think of this as A, structured information, and B, representing and revealing the structure of information in really key ways, and that different perspective is really important to really understanding the role that vector databases should play. Is that kind of the right way to think about it?
Yes, and I think what's getting mixed up in this, right? So for very obvious logical reasons, is the psychology of somebody new joining the party, right? So we have all these database companies, and they're doing their thing, and then all of a sudden they see a competitor pop up, right? So another document database, another time series database, another graph database, another data warehouse, and then you kind of use it. But now there's like a couple of new kids on the party, and they go, no, we're not. We're just doing something new. We're standing in the corner here, sipping our cocktails in the infrastructure space. Don't worry about us. We just do something new with these embeddings. And that makes some people a little bit nervous, right? So like, oh boy, what are they doing? How are they doing that? That is perfectly fine, right? That is the knee-jerk reaction that you would expect. So the problem, however, that comes out of that is, unfortunately, it sometimes happens that we forget a very, very important player, the most important player in this whole, and that's the user. Because the effect of this is that we confuse the user. And that is something you have to be careful with.
100%. And I think, by the way, this is going so fast there. I want to do some more time to do this. We got to do another podcast around this because we haven't even finished this up. But I want to close with that because that was super key on the user. I remind everybody that data and knowledge management, we've been looking at this from a technical perspective, but this is really a social technical kind of paradigm. And we just love to think about the systems, but at the end of the day, we are building systems, application tools, so human beings can use them and answer questions and solve problems. So there's not just a one size of silver bullet. Let's understand who those users are, understand what they're trying to accomplish, and that's how we find success. And then at the end, those users don't give a fuck if it's a vector, blah, blue, blah, 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 blah.
Exactly. So back to my avocado metaphor. I'll promise you I won't. But if we have an avocado, do we eat the flesh or do we eat the pit? Right? The user eats the flesh. Right? So it's the developer experience that we give people around that core database, how they interact, how they build applications. And that's also why I'm saying it is great that these existing databases add vector embedding support, because that shows there's a need. But if you want to build AI native, so if you want to have the tooling, if you really build an AI app, that means that if you take that model out of the app, your app is dead, right? That's what we do, right? And that's the difference what a vector database company like us tries to accomplish, as opposed to somebody and it's great if you can use it in something else, do it. I mean, if you have a very strong graph database, there's a new startup that I spoke to that is using both Neo4j and Weaviate next to each other to build what they're doing. Beautiful, great, right? And that's what's emerging now. So I think that's a beautiful thing. So, but it's the way that people interact, and I do argue that I think that's something different than NoSQL.
Mm-hmm. So we got some lightning round questions here. We'll do quick yes or no. All right, so I'll kick it off. Number one, do you think the AI stack is becoming pretty clear, or do you think there's still very much in flux?
In flux.
Second question. We mentioned today about the LAMP stack and the mean stack, and just zooming on the mean stack, right? I think that was a very interesting phenomenon, right? And still around, right? And it very much democratized this sort of app boom for web apps and mobile apps, right? Do you see something similar that will happen with AI? Like, is there going to be this boom where everybody's like building AI apps, right? Or do you think that's not the right corollary?
No, absolutely. So that will absolutely happen, but that is still moving. It's still moving about, and it's still, as we mentioned, it's still in flux. So will it be there? Yes. Will it have the same ingredients with this new thing of models, infrastructure, frameworks? Yes. Mm-hmm. And a language, by the way, so a core language. But we don't know yet what it will look like, because all of a sudden you think, oh, wow, look at Mistral coming up. And then boom, there's Databricks with something new. It's still happening. We are still doing, there's now this formal structuring of prompts, like with stuff like DSPy. We're doing a lot of work at that as well. Ooh, that's amazing, right? And that's all being incorporated and being made part of it, and what have you. But I think that the format, models, infrastructures, language, framework, that will stay.
Love it. Next question. There's a lot of focus on the models now. Do you think the model layer will become commonplace and commoditized?
Yes.
All right. I love it when there's like your
I like your competitiveness. Yeah. All right. Final lightning round question. So obviously the vector database space, which Weaviate is a part of here, is really booming, right? It's blowing up. Do you think that several or multiple vector databases will succeed, maybe specializing in different things, or do you kind of see there's going to be a winner?
Oh, there won't be. So it will specialize, right? So you already start to see that, right? It will. The open source, closed source thing is happening. That's also exciting to see unfold. I think there are like two axes how you can look at it: open source, closed source. Just for listen, I don't mean. Okay, this is not a very lightning answer, but if you forgive me for. I was so fast with the previous answer, so now I'll take some more with this one. So exactly. So you can plot on two axes, right? So open source, closed source. Always say no religious about open source, but open source is three things: infrastructure, community, and deployment options, channels, right? That's what open source brings us. So two axes: open source, closed source, and then we have like focus. So we believe that a lot of power sits, back to my avocado example, in that flesh around it. And others believe that it sits more in the pit. And that is kind of how it's evolving. But I believe that we must keep focusing on making the user successful building with AI. And it sits surprisingly often in the developer experience and how people interact with the database.
That's
again, love how we're closing with the user. All right.
Yes.
Wrapping up a couple more minutes here. Tim, take us away with takeaways. Here we go.
Right. So much good information here, Bob. I really appreciate you walking through, what is a vector database and some of the key applications here. So we started off with Honest OBS. What is a vector database? And you mentioned that it is a database that really treats vectors embeddings as a first-class citizen, right? You have time series databases that treats, time as the main dimension and time-stamped information as the main data, right? Graph databases it really focuses on nodes and edges. Vector databases focus on vector embeddings. And you mentioned vector embeddings are as old as math, maybe not exactly literally, but also not too far off in terms of, sort of a vector math was created. This was really key, right? And you mentioned that, there's kind of three different types of models. You have generative models, you have re-ranker models, and then you have embedding models, right? Where you're kind of getting back an array of numbers, spatial representation of the data, and especially the embedding models are the ones that you're using these vector databases for. In addition to being able to store these embeddings, you're able to run algorithms like nearest neighbor to very quickly, performantly search and interact with and do all sorts of interesting use cases and operations on those vector databases. When we asked you, like, is it just a feature or is it a database? Is it just a feature? You mentioned, well, yeah, yes, it is, but you could say the same thing about any database out there, right? Is being able to store and query JSON a feature? Yeah, it's a feature, but you look at MongoDB and they're a highly successful company focused around just that feature and optimizing not just the sort of the performance and the kernel around it, but also the actual developer experience around it, right? And then finally, before I pass it to you, Juan, we talked a little bit about, AI native applications and the stack. You mentioned that there's an AI stack forming, the lingua franca in AI is not JSON, though, right? In JavaScript, like, the mean stack and things like that. It's Python, right? And so the AI stack really is around how do we make this Python experience really, really great to create these AI experiences. Juan, what about you? What were your big takeaways?
Yeah, so what's the AI stack look like today? I like how you presented this. You have the models, right? The majority now consume via APIs. That for production use case, this can sometimes be suboptimal. That's what we're talking about. These things is kind of in flux. Infrastructure, we have model serving, we have vector databases, and then we have that glue ETL orchestration tooling, right? Things like LangChain and so forth. Really interesting. You say questions that play key roles around the models. Think about the cost, the latency, the accuracy, and actually the business model of that model is interesting, right? It's stateless. It's like an MP3 file is out there. So I found that really great. I really like that analogy. On the use cases here, right? Low-hanging fruit was better search and recommendation. Second, RAG, but I think the evolution of RAG, what we're seeing is in the third use case you brought up was this generative feedback loop. Because if you look at RAG, it's just like this one-way street, and you really want to be able to kind of what comes out of that, bring that back into the vector database, and essentially you're providing CRUD access into the vector database. So I think we kind of concluded that the vector database are not just unstructured. Embeddings are a different way to reveal that structure. And following our metaphor, by the way, it's in several episodes in Catalan Cocktails, we have this issue. We just got in a metaphor. We keep banging that metaphor. And today was one of those on the avocado. I love this. So do we eat the flesh or the pit? Of course we eat the flesh. It's all about the users and people giving that developer experience, using apps to solve their problems. Let's make users successful. Bob, anything we missed?
Nope. That was a beautiful recap. Thanks, guys.
There are only humans involved here. No. All right. To wrap up really quickly, what's your advice? Who should you invite next? What resources do you follow?
The advice is be kind, like how we started, right? It's so exciting what's happening in the space. Let's help each other be successful, right? What was the second question?
Who should we invite?
Who should you invite next?
Did you already have Paul on?
No, but we should have Paul.
Yeah, Paul
Grove, yes. Yeah, Paul and I have been collaborating for a long time, so it's time for him to be on the podcast.
Yeah. And resources. What do I read a lot? Boring answer. YouTube.
Actually, I don't think a lot of people have actually brought up YouTube.
It's not stated often enough. And honestly, Bob, I spend a lot of time learning things on YouTube, right? I'm like, I want to understand LangChain a little more. Oh, that's a good video, right?
Yep. Yeah.
Okay. Bob, thank you. Thank you so much. This has been an awesome conversation where we went through so many different parts. And I think this is going to be part one because I really want to go set up more. There's a lot more. We didn't talk about agents. We didn't talk about kind of bringing all the different types of databases and tools. Anyways, so much to talk about later on and applications and users and so forth. Bob, thank you so much.
Thanks so much for having me, guys. And cheers. And you know where to find me.